Okay, so we're looking at some more examples. Don't forget that page which are properties and laws. So now we do a combined one. Example 1. Solve we are solving for x. A log x plus 3 is equal to 2. That is A. B log 2 x minus 1 is equal to 3 minus log 2 x plus 2. We are finding x. Solution. For the first one, we remember that when you have log like that, it's the same as you have seen log to the base 10. So when you're copying the question, you can put the base is equal to 2. From there, we know that x plus 3 will be the same as 10 to the power 2. So we have x plus 3 is equal to 100. And so x is equal to 97. That's how we find x. So that for B, since we have log 2 on the left and another log 2 on the right, so bring it to the left to come as a positive, and then we have everything equal to 3. But we know that when there's a plus, there's a law which says you can bring these together by multiplication. And then you would raise, so say this is the same as x minus 1, x plus 2 is equal to 2 to the power 3. So we have x squared plus 2x minus 2 is equal to 8. So that we have a quadratic x squared plus x minus 10 is equal to 0. That's what we have as a quadratic there. Then, of course, we won't have two numbers that when we add, we get 1 and multiply, you get 10. So we use the formula. We'll have negative 1 plus or minus the root of 1 plus 40 over 2. These are the values of x. Any question?
You can go through question B. I come up with 40 and others.
This is the formula here, the quadratic formula over 2a. So I have solved this x squared plus x minus 10 is equal to 0 using the formula. Along the Rabbi says we should repeat a. For a, when you have log something and the base is not stated, you know that the base there is 10. So you place the base, and then since you are solving for x, this is an equation. You raise 10 to the power 2 is equal to x plus 3. I can't get you. Any question? Someone was saying something in the background. Network is too poor. Okay, so after you raise 10 to the power 2, you equate it to x plus 3, and then you get x to be 97. For b, you do the same thing. Having this base 2 the other side, when we have another base 2 here, we take this the other side so that we have log 2 is equal to the constant alone. Now, when there's a plus, there's a law which says if you have a plus, you put them together by multiplication. And then you raise 2 to the power 3 equal to this product here. So now you have a quadratic to solve. Because you can't find factors, we use the formula. That's how we understand this. Okay.
So
Hello?
So what if the logs are different bases? How would we do it?
Yeah, so now example 2. Example 2, you solve for x, a log 3 x plus log x 3 is equal to is equal to 2. Yeah, let's make it. Okay, is equal to 2 just like that. Is equal to 2. The bases are different and they're looking for x. So the first thing to do is you change everything to this periodic base. You can choose to change to fix base 3 and change x to base 3. So that we'll have log 3x plus log 3 over log 3x is equal to 2. So just change the base here. Using the change of the base formula, which came as a law. Then we cross multiply. So I'm multiplying everything by log x to the base 3. So have log 3x squared, because you're doing this multiplied by this. Then the middle one plus this whole thing here multiplied by this one. You will see that this piece and this one will cancel. So we'll have only log 3 remaining, but log 3 is 1 is equal to 2 log 3x. Then from there, we can let, so that we see that it's a quadratic, we can let maybe y be log 3x, so that where there is log 3x, we substitute y. So we'll have y, it will be squared, plus 1 is equal to 2y. From there, we'll have y squared minus 2y plus 1 is equal to 0. Then you solve a quadratic. The factors are there, minus 1, minus 1. So we get y minus 1, minus y, minus 1, y minus 1. So that we get y minus 1 is equal to 0. So we have y is equal to 1.
Can you please see the previous code? I was logged out. All right, thank you.
Okay. Okay. So now we are saying y is equal to 1. And yet here y is log 3. So this means that 1 is equal to log 3x, which means x is the same as 3 raised to the power 1. So x is equal to 3. We have found the value of x.
So can you please go through this question just one last
Okay.
time? I was logged out.
So the key thing is that when the bases are different, you first change the base, you fix one base and change the other. So we've chosen to fix the variable, the constant base and change the variable base. So we change log x base 3 plus log 3 base x. So we change log 3 base x to base 3. And the change of base formula, we have log 3 base 3, then over log x base 3, giving us 2. And then we're looking for x. And we have x sitting in 2 different places. So we cross multiply so that you can try to put the x's together. But when you cross multiply by log, x3 here, you get that this one multiplied by this will give us the log squared. Plus this whole thing here multiplied by this. Since this is the same as that, they will cancel. So here we just remain with log 3 base 3. But log 3 base 3 is 1. When the law which says log a base a is 1, we have 1 there, is equal to 2 log x base 3. And then if you look at this guy is squared, there's x here. This one is not squared, there's x here. So what do? We let the whole log x base 3 to be a variable y, and substitute where there is log x base 3, we put y. So we have y squared minus 2y plus 1 is equal to 0. From there, we solve a quadratic. So we get y is equal to 1. Now when y is 1, remember y came in to represent log x base 3. So when y is 1, it means that log x base 3 is 1. And so we can raise the base to the power 1 and we'll get x. So x is equal to 3. That's how you obtain x. And that's how you solve the logs when it turns out that they become quadratic, they form quadratic equation.
So repeat the last part. The last part.
When you are done finding this variable here from the quadratic, your job now is to go back to your left and check. You said y is equal to log x base 3. Now when y is 1, it means that you go back to this equation here, formed by yourself. Where there is y, you substitute a constant. Sometimes you can find different values. So you substitute 1 at a time. And then you raise the base to power this thing here, you get the variable inside. So x is equal to 3 to the power 1, which is equal to 3.
Thank you.
Okay. So we do another one. Why did we square that log 3? Because we are multiplying two logs. We have this log x3 and another log x3. So log multiplied by log, you get log squared. Just like x multiplied by x is x squared, so is log. B. Still looking for x? Hello.
When finding the value of x, why didn't we go back to the initial equation? Why did you just select only one equation?
What do you mean by the initial equation?
The first equation that we had, that one for log base 3x plus that one, why didn't we use that one when finding the value of x?
So we have used this one. We have used this one to give us a simpler expression. And then this simpler expression that came from this one, we left it here by getting another simpler expression where we have y representing the log. This whole question depends on the log. So we're looking for a way we can extract the x from the log. So at this point, we're not able. So what have we done? We choose y to represent the log and then substitute. So this whole process here is for this. This one here is now extracting the x from this whole thing. So it's still the same, except that we cannot go back in this one because there's no y here. So we go back to where we left this when we introduced y for us to find x. Okay. B. Ln x plus ln x plus log x e. We put a 2 here. Now let me put a 2 here. Is equal to is equal to 3. Is equal to 3.
So wait, on the previous question. Yes. Where did you get this log 3, which is outside the brackets? Like, how did you factor it out?
So we're just multiplying everything by what is in the denominator here.
Okay.
So how to get rid of it?
All right.
So I have another question here. Ln x plus log x, plus log e squared base x is equal to 3. So same story. So I don't do. So let me make, yeah, this one negative. Okay. So now we know that ln is the same as log ex. Whenever you see ln, you know you have seen log e. Minus, we have a property which allows us to drop the power. So we'll drop the power and then have log x e is equal to 3. At this point, we'll change the base. Now we have x, we have e, we also have x. So let's change everything to e so that we have log ex minus 2 log e over log ex is equal to 3. So that,
So,
hello.
how can we change log, if you want to change the same log e to the base x, now we want to change it to log to base. We want to keep it in base x. Is it possible?
To keep x as a base,
Yes,
it's possible.
yes, we say it's possible.
Yes.
We say log x.
Or, okay, let's do this. Since on the previous one we changed to a constant base, for this one, let's change to a variable base so that we understand it also in that way. And then for us to have solutions, we need to, let's see, it will be y squared minus 2 minus 2. Supposed to be y squared minus 2 plus 3. Okay. So we make this guy 3, this plus, and this one 2. Okay, so we'll solve now, changing to, we'll fix the x.
Sir, changing
Yeah.
the equation. What was wrong with the first equation you wrote?
Now I'm trying to look for an equation that is going to give a solution. What I have here is 2 plus 3. Y is 0. Here I want our factors. But when it was like this, we still don't have factors. Now we have -2 and -1. Okay. So which one should be negative? So this one remains positive, and this one remains positive. So, okay, let's go back to our normal question. That was okay. So now we want to solve it by fixing x. So say we have log ex plus, we drop the power 2, and then we have log xe is equal to 3. Then this is log ex plus 2 log, so we're changing the base to x. So we change the first one, it will be log xx over log xe plus 2 log xe is equal to 3. So this one becomes 1 over log xe plus 2 log xe is equal to 3. Then you multiply throughout by the denominator, so that we have 1 plus 2 log xe squared is equal to 3 log xe. When you cross multiply, so say this multiplied by this, the denominator will cancel. That's the reason why we're multiplying by the denominator throughout. Then this log multiplied by log will have log squared. Then 3 multiplied by log will have 3 log. And then at this point, we let y be log e base x. Then we substitute, so we have 1 plus 2y squared is equal to 3y. We arrange this, we have 2y squared minus 3y plus 1 is equal to 0. The product 2 times 1 is 2.
Excuse me, sir.
Hello.
Where is the one coming from? The one over log.
So remember that we had this law yesterday, which was giving us 1. So what we have here is log x. So it's the same as log AA, giving us 1.
Sir,
Hello?
on the third step, why is it important for us to multiply it with that number?
We want to
Like
get rid
when
of the
we're
denominator.
multiplying- Oh, right.
So when you're solving for x,
Why
and
are we
x is
taking
in
the-
2 parts. You're solving for x, and x is here, the other x is there. How do you find it? You try to put the x's together, because you're solving for x. So you're trying to find a way of correcting the x so that you can put them together. Now that we have a quadratic with factors, the product is 2 and the sum is -3. So So the factors will be -2 and -1. So get 2y, y minus 1, y minus 1 is 0. So we have y is equal to 1 or y is equal to half. Then you go back to what y is. So what is y? Y is log e base x. So when y is 1, we have log e base x equal to 1. So x to the power 1 is equal to e, telling us that x is e, or when y is half, we have half is equal to log e base x. Again, x to the power half is equal to e. We square, because we are looking for x, we square. So we get x is equal to e squared. So we have the values of x. So you can solve it in any way. You still get the same solution.
Sir.
Sir, like
Hello.
for me, I didn't use x as my base, but I found y to be 2 and y to be 1.
But still find the same values of x, is it?
Yes,
Yes.
but the value of y was 2 and 1.
So the value of y depends on the value of y depends on, the value of y depends on your choice. Our interest is the x. But as long as the values of x are the same, then we are okay, because we are solving for x. Another question? Another question?
Like why are we squaring the x to the power half?
We are solving for x. So when x is in the root and you want to find the value of x, you square and square so that x can be alone. So that's when you say, I found the value of x.
Oh, okay. Thank you, sir.
So once it cuts, we quickly join in the last minute.
I understand. Sir, sir, we have another class also, right?
We have another?
Another class after this one, or just this one for 2 hours?
No, we are joining immediately. And then you have another class at 15. So let's join.